Welcome to this training session on C++. This is a version 2018 implementing 3D feature, and this video is intended to demonstrate how to quickly start with 3D geometry and build from a mesh sound transmission model using all the new features. So compared to older version, you have a new 3D geometry tab. You can also find this tab here if it is not apparent above the toolbar. I click here, and this is the new model constructor window from which all subsystems can be created from the geometry. And you will have three successive objects you have to handle. First object is a PID of the mesh. This is an intermediate object called shape. The shape includes the geometry of the selected PID and some measurement or length and angle which will be determined to be the input of the subsystem. Then first step is then to load the geometry in our model. I import the geometry for Nastran. It's a plate cavity coupling. Alright, made of 4 PID, check all. Always right menu to handle. You can see the geometry, you can see the geometry and the element here. And expand the geometry to have a little bit more view. Coming back to PID view, we see that we will have some faces defining a separation wall between the two cavities and the test panel. And what we have to do is to transform this PID information from Nastran directly into shape, from which we will create subsystem. When the software is able to do it, it already decodes the sum of the PID and transform it into shape, like for example, the test panel, PID4. I had some name, which is a panel 3 meter by 2, we found it. And this shape is a user-defined shape. So the geometry is not really important. The data associated to the geometry are not so important. What we have to do is to create a shape from the other PID. PID1 is a wall. And the wall is selected and transformed into a plate shape. Per default is a 10 by 10 wall. And the PID3. PID3 is this set of face, and I click and make a user define from it. Then I have all the required shape information necessary to build up my subsystem. Well, PID will be the wall, and PID2 is on the left will be the emitter cavity. And PID3 obviously it's a receiver cavity. How to do shape from it? For the panel it's very simple. I just unclick here for having a better visibility, and then I can create a subsystem from this shape by clicking here in the panel icon, and automatically it set up the geometry correctly from what have been determined in the shape. The property is not correct because the wall is a concrete wall 1 meter 6, so I have to create appropriate section. So wall section in concrete, 1 meter thickness. And I click OK. Then I have to create, or you see the subsystem have been created. It is green. It's a new object, in fact. when we click here, the shape associated to this wall is blue. Now I'm clicking on the test panel shape, and I'm clicking on it and creating an SCA panel from it, 1 millimeter aluminum here. You see the shape is loaded inside the subsystem under Geometry and Trim tab, and you can do it manually as well. And I click OK. And now a second subsystem has been created, the test panel. Now we need to create the cavity, and for that we need to have an enclosed volume. We can use the emitter, the test panel, and the wall to have a closed volume or shape, and then I can select all this shape and directly generate an acoustic cavity from the shape. And I click OK. And I will call it PID, it's mainly PID2 emitter cavity. PID3, I do the same. Select all face of this volume and create an acoustic cavity from it. This is the receiver. And it's okay. And the receiver, I will calculate the absorption for trim with a background absorption of 1%. So now I have all my subsystem, 2 cavity and 2 plate, and now I want to couple them. To couple them, everything is going in this panel. You can also connect shape, but for the moment we just connect subsystem together. First I have to connect subsystem on the right face, because here it's a flat panel, and then there is 2 face, Z plus and Z minus, and we can say it on the corresponding shape. If I unclick the cavity, you see the wall and the test panel have a normal oriented in that direction, which is here the direction of positive Z. And then the other face will be named Z minus. Then when I go back to the subsystem panel, I just click here and here to connect the emitter and the wall, and click on this icon here, and as default is connected on Z minus, so which will be the good side of the panel. Then I go to wall and receiver cavity, and in that case I have to connect on Z plus, because the default selected face is always Z minus, and I click OK. Then the wall is connected to both cavities, so I do exactly the same for the panel, connected on Z minus, then connecting the panel to the receiver cavity on Z plus. But I need to deselect the junction for better selection effect. Panel to cavity, connect, and Z plus. And that's done. So I've connected all my cavity together. I have then 4 coupling loss factor, 4 connection. Still one remaining connection is a 2 panel together. So I select the 2 panel and then click OK to detect the mechanical junction, which will be a line junction here. 2 panel are coplanar and 180 degrees with a line junction of about 10 meter length. And the junction is seen as this red line here. Then we have coupled all the subsystem. What we have to do is then, so we have this test panel to test panel, to wall, test panel to wall. Now all we have to do, the remaining task is to add a trim to our panel. So I will connect the trim on the Z plus face, and to do that you go to geometry and trim. Then you go to trim. In the Z plus tab you just insert the trim, fiber, thick panel, and you click OK. And then it's finished. Your model is okay, and the trim has also been allocated to the cavity face, as you can see, and it participates in that case to the absorption inside the receiver cavity. And now, because we have all the ingredients, we can export the model to the C+ page to load it. Here the model. If we plot everything, we see there are the junction there. I disable the junction. And now I will just add a source as an energy constraint with unit pressure, constraining the emitter cavity. And then I can solve this problem. And plot resulting acoustic pressure. This is our result. What we can do again is to plot the power flow. For example, at 1000 Hertz. And for this, to visualize the power, I had to shift in the icon view. And in icon view, we see at 1000 Hertz that there is most of I will reduce the dynamic range to 30 dB. Not enough. 50, 60. Most of the energy is coming through the panel. But there is nevertheless a significant energy transmitted from the wall, because the wall is really, in that case, weakly damped. So if I remove the plot, we can improve a bit the visibility of the 3D icon by separating a little bit more efficiently the coupling loss factor. And here we are. So we can see the view in either icon view or either geometrical view. It's up to you. When you want to see, for example, the connection with a plate, I mask the junction. You see the connection. So the best way to navigate in the model, of course, is to use this feature to simplify the diagram. work also in 3D. Okay, thank you very much for your attention. I hope you will enjoy this new feature, and the next session will be about updating new model. Thank you very much.